Hi, I'm Adam Porter, and this is Programming Mobile Applications for Android Handheld Systems.
In our last lesson, we talked about the four fundamental components of Android applications, and they were activities, services, broadcast receivers, and content providers. Today, we're going to take a deeper look at one of those components, the activity class. I'll start by presenting the activity class itself. Next, I'll discuss Android's task backstack, which helps users easily navigate back and forth among the activities they use. After that, I'll discuss the life cycle of activities, how they're created, executed, and terminated, and how Android manages and communicates these life cycle phases and changes to your applications. After that, I'll discuss the APIs and patterns that you'll need to programmatically start activities. And finally, I'll finish up with a discussion of how Android activities handle device and application configuration changes. As I've said before, activities are the primary class for interacting with users. They're designed to provide a visual interface through which the user can interact with the application. And by convention, activities should be modular in the sense that each activity should support a single focused thing that the user can do with your application. And individual things like viewing an email message or showing a login screen. And if you follow this convention, then you end up creating applications by stringing together multiple activities, each with a single purpose that the user then navigates through. And Android helps users do this navigation in a couple of ways. By supporting the concept of tasks, by providing a task backstack for managing the specific activities through which the user is navigating, and by ensuring that activities are properly suspended and resumed as they're pushed on and popped off the task backstack. In Android, a task is simply a set of related activities. These related activities can, but don't have to be, part of the same application, so tasks can span multiple applications. And most tasks start at the home screen. So when a user launches an application from the home screen, a new task is normally started. And when a user hits the home button to return back to the home screen, the current task is at least temporarily closed. The task backstack works as follows. When an activity is launched, it's pushed onto the task backstack, normally as part of the current task. When that activity is later destroyed, for example, because the user hit the back button, because the activity terminated itself programmatically, or even because Android itself has decided to kill that activity in order to reap its resources, then the activity is popped off the task backstack. Let's take a look at how this process works. Now, this graphic represents an activity that's running on a device and depicts the state of the task backstack while the application is running. The black pointer at the bottom indicates the current snapshot. Now, when this application is first launched, it starts up activity 1, which is then pushed onto the top of the task backstack as the root of the current task. Now, as you can see, activity 1 has a single button labeled Start Activity 2. So the idea here is that if the user presses this button, activity 2 will start. So let's say now that the user presses the activity 2 button. At this point, activity 1 is suspended, and its state will be captured so that it can be restored later if the user returns back to it. Next, activity 2 begins, and activity 2 is pushed onto the task backstack. Now, similar to activity 1, activity 2 has a single button labeled Start Activity 3. If the user presses this button, activity 3 will start. So let's say that the user now presses the Start Activity 3 button. At this point, activity 2 will be suspended, activity 3 will begin, and activity 3 will be pushed onto the task backstack. Now, let's say that the user has had enough of activity 3 and hits the back button with the idea of going back to activity 2. At this point, Android kills activity 3 and pops it off the task backstack. Now, because activity 2 is currently at the top of the task backstack, Android will unsuspend or resume that activity, restoring its state and bringing it back into view on the device. Now, as we saw with the task backstack examples, Android activities come and come again and go away for good. They have a life cycle. And importantly, for you as a developer, your applications are not really in control of this life cycle. Some life cycle changes, for example, depend on choices that the user makes, like pressing the back button or the home button. Other life cycle changes depend on Android itself. For example, if your device is running low on memory, Android can decide to kill activities that are currently suspended, and it'll do that knowing that it will need to recreate them later if the user navigates back to them. So let's talk a bit more about the activity lifecycle and the particular lifecycle changes that activities go through. For example, once an activity is started, it can be in a resumed or running state. And while it's in this state, the activity is visible and the user can interact with it. An activity can also be paused. For instance, when a new activity starts to pop up in front of it. In this situation, the activity may still be partially visible, but the user can't interact with it because the user will be interacting with a new activity that's starting up. Prior to version 3.0, Android could terminate activities once they went into the paused state. Now finally, the activity can be stopped. And when it's stopped, that activity is no longer visible, and Android is free to terminate, and this is important to reiterate, it can terminate stopped activities, and it does so knowing that it might need to recreate them later if the users navigate back to them. Now, your activities will often need to behave differently during different parts of their life cycle. For instance, if your activity is showing an animation, but then pops up a partially transparent dialogue style activity in front of it, well, you might want to pause the animation while the user responds to the dialogue, and then restart the animation once that dialogue activity finishes. In order to support scenarios like this, Android announces lifecycle changes to your activity by calling specific lifecycle or template methods. And some of these methods are shown here. And each is named, as you can see, on something or other. On create, when the activity is about to be created. On start, for when the activity is about to become visible. All the way to on destroy, when the activity is about to be destroyed. And if you want to take some specific action when your activity changes state, then you need to override one or more of these methods in your activity. So let's take a look at how these different methods interrelate with each other. Now this graphic depicts the orders in which activity lifecycle methods can be called. And the important thing to remember here is that Android applications don't work completely by themselves. Instead, there's a clear back and forth collaboration between your application and Android. And you have to understand the rules of this collaboration if you want your Android applications to function properly. So let's imagine a simple application with one activity that starts up, waits for a moment, and then exits. In this simple case, when that application is launched, Android will call the activity's onCreate method. Then Android will call its onStart method. And then onResume. After which the activity's user interface will appear on the device's screen and the user can interact with it. After a minute or so, our example activity will begin to shut down. And at this point, Android will call that activity's onPause method. Then onStop. And then finally onDestroy. And at this point, the activity is completely dead. So, as you can see, the entire lifetime of the activity runs from the start of onCreate to the end of onDestroy. Now, when this simple activity started, it wasn't visible on the screen. At some point, it became visible, and at some point later, it became invisible as it was removed from the screen. When activities are about to become visible, Android calls the onStart and sometimes the onRestart method. When activities are about to become invisible, Android calls the onStop method. And so you can think of the visible lifetime of an activity as occurring between the start of calls to OnStart and the end of calls to OnStop. And finally, while an activity is visible on the screen, there are times when the user can interact with it, and there are times when he or she can't. And for example, this can happen when a device goes to sleep. In that case, the user can't interact with the activity anymore, even though it still is the foreground activity. So when activities are about to be ready for user interaction, Android calls the onResume method. When activities are about to stop being able to interact with the user, Android calls the onPause method. And so you can think of the visible and in foreground lifetime of an activity as occurring between the start of calls to onResume and the end of calls to onPause. Let's walk through an example of this based on the map location application that we saw in earlier lessons. First, the user goes to the home screen and launches the map location application. This causes the map location activity to start up, at which point Android calls map location's onCreate method. OnCreate initializes the activity, and then Android continues by calling onStart. And at this point, map location is visible, but not yet ready for user interaction. Android now calls onResume. After onResume completes, map location will soon be both visible and ready for user interaction. And at this point, the user will normally enter an address in the address box. Once the address has been entered, the user will normally press the Show Map button, which will launch Google Maps. Now, as Google Maps starts up, it will have its own initial activity that will go through its own life cycle and receive its own life cycle callbacks. But let's continue looking at what's going on with the map location activity. Now, because Google Maps is about to come into the foreground and cover up map location, the map location activity will first receive a call to its onPause method. And soon after this, map location will no longer be visible, and Android will call its onStop method. Now, eventually Google Maps will appear on the screen, and the user can interact with it. But at some point, the user will be done with Google Maps and might, for example, choose to return back to map location, for instance, to map a new address. So let's assume that the user now hits the back button to return back to map location. At this point, map location must be brought back into the foreground. So as Android does this, it will first call onRestart, and then onStart, and soon after this, map location will again be visible. Next, Android will call map location's onResume method, soon after which the map location activity will be both visible and ready for user interaction. And finally, when the user eventually loses interest in map location, he or she might hit the back button again, in this case to end the application. At this point, Android will again go through the process of removing map location from the screen. It will first call onPause, then onStop, and then this time it will call onDestroy before completely terminating the application.